Alright, so we're going to look at another transformation, and this is what happens when you multiply the x squared by a number. This is a stretch or a compression. Okay, so if the coefficient says the absolute value is between 0 and 1, then it will be wider than the graph of x squared, so that's a compression. If the absolute value is bigger than 1, then the graph will be skinnier. It's a stretch. Okay, so this is absolute value. It doesn't matter if it's positive or negative in terms of the stretching and the compressing. If it's positive, it turns up. If it's negative, it turns down. It kind of goes with those properties we learned in the last section. Okay, so let's graph 3x squared. Okay, so we're going to kind of do the same. We're going to graph the basic y equals x squared and then see what happens to it. Okay, so we have 0, 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. Alright, so this we have our graphs right here. 2, 4 to negative 4. This is our original x squared graph. Alright, let's do the next one. So we have x and y equals 3x squared. So 0 is going to be 3 times 0 squared, which is 0. 1 is going to be 3 times 1 squared, which is 3. 2 is going to be 3 times 2 squared. 3 times 4 is 12. Negative 1, 3 times negative 1 squared. 3 times 1 is 3. And for negative 2, 3 times negative 2 squared is 3 times 4, which is 12. Okay, so we have 0, 0, 1 and 3, negative 1 and 3, 2 and 12, 9, 10, 11, 12. 2 and 12, negative 2 and 12. Okay, so we're going to do the parabola. Basically, notice that all the y values were multiplied by 3. So it's kind of steeper. It's stretched out. Okay, so because our a value was, the absolute value of the a was bigger than 1, we got a stretch. So this is called a vertical stretch by a factor of 3. So it's pulled up. Okay, now it kind of changes shape. So it stayed in the same place, kind of the vertex, but it got stretched out. Think of like taffy.